A very good morning to all my dear friends. Welcome to Unacademy. So कैसे हो मेरे प्यारे दोस्तों? So चलिए guys, आज start करेंगे हम अपना session on permeability. Okay. So we have completed so far clay mineralogy and now it is going to start permeability, and after that the sequence would be seepage. Then we will be talking about effective stress like that. तो इस तरीके से हमारा चलेगा कोर्स। चलो स्टार्ट करते हैं। बिफोर दैट लेट मी हैव द क्विक इंट्रोडक्शन। मैं हूं आप लोगों का दोस्त ऐश्वर्य, यूज्ड टू टीच यू फॉर गेट एंड ईएससी। आई हैव डन माय एमटेक फ्रॉम आईआईटी दिल्ली एंड बीटेक फ्रॉम जामिया मिलिया इस्लामिया। 4 times I have qualified GATE with my best AIR 2 to 6, and I do have 7 years of teaching experience, 2 years of industrial experience, and all these are the subjects which I am basically taking on Unacademy official YouTube channel, Unacademy special classes, as well as on Unacademy Plus. The subjects are theory of structure, RCC, geotechnical engineering, strength of material, and even your engineering mechanics. And this is a code which you can apply before buying any Unacademy Plus subscription. Okay, if you want to avail 10% off on Unacademy. Soon this 10% is going to become 5%. So if you are in need of Unacademy Plus subscription, then better to plan it early. And this code is applicable not only in GATE and DSC, it is here as well always, but it is also available for various other competitive fields. So you can consider this code as an universal code at Unacademy, because you will be able to keep this code in all the competitive field. Okay, whether it is SSC JEE, IIT JEE, civil services, okay, bank services, etc. So it is applicable actually everywhere. So that is why I am calling this code as the universal code. Okay. And now the question comes into mind that why do we need Unacademy Plus? So at Unacademy Plus, you can get the access to daily live classes, crash courses, weekly test, doubt solving sessions. It is available in both the languages, English as well as in Hindi. Rank improvement batches are also there. And my dear friend, if you want to convert simply this plus experience into your personalized coaching, then you may go for our iconic plan, which is considered as the superset of plus subscription. Because in iconic plan, we are going to give you, assign you a personal coach, which is also known as local guardian. First of all, make sure that whatever are the stuff in plus, automatically by default you are getting in iconic, but other than plus these things, what else you are going to get? You are going to get a personal coach, also known as your local guardian, and this of your local guardian will be helpful for you planning your studies. He is going to keep the study booster session for you, and you are going to have the analysis on your test, and based on your analysis the exact you can say analysis will be conveyed to you, and you will be letting to know that what all are the areas where you guys are lagging and leading, and what could be the revised strategy based on your subject test and all. Okay. And they are also providing you specialized notes and practice sets. So doesn't matter if it is a matter of plus or iconic, so my code you can always use. Okay, so you will be getting benefited by 10% in each and every segment. Okay, now my dear friend, here is the information on our upcoming batches. So this batch, evolve batch, is started on 8th of February, where our top educators has initiated this. And if you want to be a part of this, use the code S10. Okay, and similarly my dear friend, there is a ascent batch for gate 2023. It is the batch D. Okay, so it also started on 8th of February, and this is targeting your 2-year plans. Okay, for 2-year strategy it is going to give you. And here as well, if you want to enroll yourself for here, then you can use my code S10. Okay, so it is about engineering services examination prelims, especially general studies, which is going to be a rank determining factor in your preparation. So for that as well, on 18th of February, means tomorrow onwards, we are going to start a non-technical batch, and here as well you can use the code You don't have to use code again and again. Even if you are using it once, then you can enroll yourself into all these multiple batches. The thing is, duration should meet. Okay, if you are buying a 2 year subscription and like that, then all these batches would be unlocked for you. Okay, so my dear friend, if you haven't downloaded the Unacademy app, then you can do it by from your Play Store, and after that you can say that you will be able to access to our special classes, or you can say free special classes, quizzes, combat, and live test series. Okay, is it clear to you? Okay. So this is all about me, an academy, and its various plans. Okay. So tomorrow we will be having a session on permeability only. Obviously, it is a big chapter. We will not be able to complete it by today, so it needs some more time. So tomorrow I am planning to continue permeability only, and today's session is on permeability. Okay, so session number 17. So once again, welcome you all. I welcome you all at session number 17 on permeability. Okay, is it clear? चलिए, तो करते हैं स्टार्ट. ए वेरी गुड मॉर्निंग शबीन, कैसे हो दोस्त? चलो तो स्टार्ट करते हैं अभी जल्दी से, बट बिफोर दैट लेट मी शेयर द लिंक ऑफ दिस लेक्चर इनटू आवर ऑफिशियल टेलीग्राम चैनल. ओके ओके ओके. Yes, so permeability, my dear friends. Okay, so it's time to start permeability. So just a quick look on syllabus, that what all are the things which we have covered so far. That it is your just a minute for comments and all. I will be using. Yes. So far we have completed origin of soil, phase diagram, soil classification, clay mineralogy, and this is our agenda for today's class. Okay. So permeability seepage combined, it's going to take you can say 3 to 4 lectures minimum. Okay. So we have to start this. So what is permeability? See, you all know that soil is having void, and through this voids, what happened? Water is trying to percolate itself, and how much is going to be the speed of water or flow of water between these voids? It depends upon the interconnectivity of them. Doesn't matter if soil is having large void or less void. Okay, permeability is a function of interconnectivity of voids. If the voids are interconnective, then you can say permeability is large, means ability to flow any liquid within the soil medium would be high. Okay, so actually you can say it is a property which is allowing to water to pass through it. Okay, the ease with which it is going to pass, you are going to say it is more permeable, and if it is becoming difficult, then you have to say it is less permeable. Okay, so as I told you earlier as well, that void ratio are going to be high in case of fine grain soil in comparison to coarse grain soil, but still the interconnectivity thing is more in your coarse grain soil. So whenever it comes to the comparison of permeability between fine grain soil and coarse grain soil, we are always going to say that coarse grain soil are having more permeable. They are more permeable because of that connections. Okay. So here it is written that, now we can read it out. Permeability is the property of soil which allows to water through its body. Okay, just a minute, just a minute. Okay. And seepage, you can say it is a process and the permeability action. And seepage is the process, and you can say it is a permeability action. Okay. And as I told you just now, that permeability of coarse grain soil is greater than that of fine grain soil. But one thing I want to say, that fine grain soil void ratio is greater than coarse grain soil void ratio. So it is very simple to imagine and all. I think I have given you the logic for this. But if it is a percolation permeability, I will say that both are the similar thing only. Sabine, for me they are same, but maybe there can be some difference in terms of you can say dimensions and all. But I'm going to consider them same, because they might be having different maybe meaning in your hydrology or irrigation maybe. But percolation also for me in geotechnical engineering is ability to pass. Permeability is also ability to pass. Okay, hydraulic conductivity is also ability to pass. So I am going to call all these terminologies similar here. Okay. Hmm. So it is like, if it is a big, you can say football, it is going to occupy some volume. When the same volume you have to occupy with the help of, let's say, small oranges, then you can say, for a same volume of a big grain, if you are going to replace them with some small grains, now you would be having much worse. So suppose one big grain where no air was there, only solid material was there. If same grain you are going to replace with the help of some minor thing, minor grains, then definitely in order to occupy this similar area, it has to have some words in between. So anyway, you can see it is going to have a very high words in comparison to the single grain. So whenever the coarse particles are being replaced by smaller particles, in that case you can say they are same. Okay, their word ratio would be more. Shamala, very good morning my dear. Okay. After that, now what is your discharge velocity and what is your seepage velocity, this we have to see. Discharge velocity is known as the gross flow velocity out of the cross section, whereas seepage velocity is known as you can say your flow velocity around the slow grains. It is also known as the true velocity. This concept is very interesting, important as well, because too frequent. It is being asked too commonly in questions are there in your ESE and GATE from here. See, whenever you are seeing that a water is coming here and it is coming out, so you are only worried that this cross section is you can say phased by this velocity, and it is this cross section is coming out with this velocity. Okay, so discharge will always be maintained. So the you can consider the average velocity from here to here as your discharge velocity. Okay, so but what is the difference between seepage velocity? Seepage velocity is the actual flow of velocity through the interconnected voids, or you can say actually your soil is going to have seepage velocity only, but due to that interconnectivity voids and due to the longer pattern and all, it might take some more time, okay, to reach from here to here. So depending upon that time, inlet and outlet time, okay, you would be getting your discharge velocity, and depending upon the actual flow movements and speed, you would be getting your seepage velocity. And if somebody asks you which is going to be more, then obviously you, from your common sense only, you can say that seepage velocity would be your greater than discharge velocity, because here it is going to be more now. Here it is going to be more. Actual velocity, let's say it is like 2 meter per second or 1 meter per second, although it is large. But discharge velocity you would be feeling only 0.5 meter per second, because you are seeing from here to here. But this water maybe have to move with more speed, then only it will be able to take all these interconnected zigzag path and it is coming out. Is it clear or not? Tell me. Is it all clear? So I just want to say that seepage velocity is the actual flow velocity it across or around the soil grain, and discharge velocity is your average velocity, or you can say it is the gross flow velocity. Okay. So how much time we are going to take from move the water from here to here in a within a given time. So based on that you guys are going to calculate your discharge velocity. Is it clear to all? Okay. So that is the concept. Now logically we can feel that seepage has to be more. Okay. Now the mathematical terms we can also check. Okay. Logically it is clear that seepage has to be more because it has to travel more path. Now what is going to happen in seepage? So that we have to see. So suppose one thing is sure, discharge is going to be constant, and if this is the cross section, okay, and if you are going to put all the vacant place like white and soil solid particles by this brown, then you can say discharges are going to be same. So anyway you can write that discharge velocity into gross area into discharge velocity. This is your discharge only. If we are going to compare it with the actual area of voids, because from void only it has to pass into, it is discharge into seepage velocity. Okay. Sir, will water flow inside the solid particle in soil? No, Shabin, never. Even if it the structure of the molecule is absorbing some of the water, we do not have to consider it. We all these things are we are going to ignore here. It is not going to flow within the soil solid. It only can flow through the interconnected voids. It can only flow through the interconnected voids. So my dear friend, this is a scenario that VD is equal to area of void over gross area into Vs, and if I'm going to multiply them, area of void into L, volume of void, it is volume of total volume, it is volume of void only throughout this length, volume into Vs. So Vd is equal to, what is volume of void with respect to total volume? Tell me. It is nothing but your porosity. It is nothing but your porosity. So here I can say that my discharge velocity is eta types of Vs. So who is going to more? Don't think that Vd is sometimes of Vs. So Vd has to be more. No. The more is Vs. Here Vs is greater than Vd, because our eta is always less than 1. So Vs is always going to be more than that of Vd. Okay. Is it clear to all? Tell me. Is it clear to all? Please let me know if you guys are having any doubt. Okay. So this is the relation between the discharge velocity and the seepage velocity. Okay. Please let me know if you guys are having any doubt so far. बताइए. Okay. So that's all. चलिए नेक्स्ट बात करते हैं। अब देखो, now the Darcy's law I want to define, but before that I want to just revise you the fluid mechanics basics only. Suppose it is a my soil sample, and if I want to check that what is the total head at this point, let me call it point as A, and what is the total head at this point, let me call this point as B. So what is the total head here? Okay, so total head here would be equal to, it may be due to the, this is datum I have so this may be your, you can say um, datum head. Okay, and up to here you will be having this potential head, or you can say pressure head. Okay, my dear friend, now I want to tell you one thing. Velocity head would also be there here, my dear friend. Your velocity head will also be there, but that velocity head, okay, let me write it now. That velocity head may be like this. It is equal to v square upon 2g. It is equal to your v square upon 2g. And similarly v at a, you can say. Similarly when it comes to b point, it is like zb, and it is just like your you can say phb, and there might be some value of you can say vb square by 2g. Okay, so the total head, if somebody asks you what is going to be the total head at a, then you have to say that total head, or total head at a is going to be equal to za plus pha plus va square upon 2g. Similarly the total head at v would be, it is equal to your zb plus phb plus vb square upon 2g. Okay, so now from a to b you will be seeing, if water is percolating through the interconnected voids, then that might be experience total head equivalent to this. These are nothing but the format total, writing total head for your pressure, datum and kinetic head, or you can simply go to this expression with the help of Bernoulli's theorem. Okay, so my dear friend, as per Darcy, if flow would be going from here to here, then definitely it would be having some velocity, and that velocity is going to, as per the head loss between these two. Suppose the head difference between A and B is more, let's say 10 unit, it is going to have some you can say velocity. If the head difference between A and B is going to be like 1 unit only, still it would be having some velocity. But you tell me from your common sense in which case it is going to be high head. Okay, or you can say high velocity. whether it would be in case number 1 where the head difference between A and B was 10 units, or it is going to be in case number 2 where the head difference between A and B was only 1 unit. So obviously you will be saying that the more energy difference is leading the flow to a greater rate. So velocity would be more where the head difference would be high. Okay, so that is going to be the case. Now after that, one thing, you cannot say that you cannot compare two scenario where the head difference is 10 or another case where the head difference is 100. It may happen that where the head difference is 10, it is only for 1 meter, and where the head difference is 100, it might be 20 meters. So what is the per unit head loss? That is also important to know, because it is also depending upon the passage and all, na, that how much we have to go. Suppose it is dropping 10 unit in 1 meter length, so it is going to have a head loss of around 10 units, 10 over 1. But if another case where the head loss is head difference is 100 unit, so that 100 unit over the length of 20 meter or 20 units, it is going to be 100 by 25. So if you are comparing both of these scenarios, then velocity would be more in case number 1 as compared to case number 2, because in case number 1 the per unit head loss is more, in fact double than that of case number 2. So that is the reason why I am saying that this velocity or the flow rate is depending upon the head difference. So head difference is going to play a very crucial role. Okay, so which head difference I am talking about? I am talking about obviously the total head difference. Okay, one more thing we have observed in the soil system. Mostly the flow in the soil are basically your laminar. They are occurring at very low velocity, because if you'll see, most of the beneath soil is having sand, gravels, clay and silt. So all these clay and silt are having quite negligible velocity. In fact, the velocity of sand and of gravels are also in the range of let's say 3 mm per second, 4 mm per second, like that. So these are really not going to contribute much. The velocity head is really not going to contribute much in comparison to your datum and pressure head. Or in fact, I can say this quantity is quite negligible for soil flow. Okay, for water flow in between soil whenever it comes to datum and potential. Okay, so we can ignore the velocity head due to the low velocity of liquid through the soil, okay, in comparison to your datum and pressure. Is it clear to you or not? So whenever in my soil mechanics, in my soil mechanics, total head, especially in case of Darcy law, or you can say your laminar flow. So total head at A, I am going to write the piezometric head at A, sorry, the datum head at A plus the pressure head at A. Now it is also known as the piezometric head, because if you are inserting the piezometer here, so in that piezometer, the rise of the water is still here. And with respect to datum, so this is the level. In order to achieve this is the level, so you have to add ZA plus PHA. So therefore, you can say this is going to be your piezometric head at A. Similarly, if you want to calculate the total head at B, so you can say that it is going to be ZB plus PHB, because do not forget I am ignoring here the kinetic head. Or we can also say that in my Darcian fluid, or which is going to about Darcy law, or in my laminar flow, the total head is nothing but piezometric head. Piezometric head is what? It is the summation of datum head and pressure head. Or in other word, I can say the kinetic head, the velocity head, I am going to ignore here. The kinetic head or the velocity head, I am going to ignore here. Is it clear to all? Tell me. Okay. Okay. Sorry. Now next thing is, yes. So as I told you, the velocity is going to depend upon the head loss over the unit length. How much that head loss has been taken. So I can say here that my velocity of flow is proportional to head loss over a length. What is head loss? Head loss, if you have to calculate, then head loss is going to be equal to, head loss is going to equal to, if flow is happening from A to B, then obviously water will always going to flow from higher energy to lower energy. So at A, if it was lower, so its head was more, so the total head had to be, so the difference of total energies between A and B is going to give you the head loss. Now obviously total energy at A is going to be higher than that of total energy at B, because in initial I have told that water is going from A to B. It is not necessary that it is oriented like this in the downward manner. That is the reason why it is going from here to here. Okay, that is the reason why it is going from here to here. Is it clear? My dear friend, if the total energy at B would have been more than A, then water would be going like this, like in case of your pressure flow and all. Most of your pipe, house pipes, in that pipe, whenever you are turning on the motor, the water is going from the lower datum to higher datum. But it doesn't mean, or lower piezometric head, lower level to higher level. Why? Because the piezometric head, or you can say pressure head, which you are going to impart at B, is may going to overcome all this pressure, datum, as well as velocity head at A. So that is why the flow is going to take place from B to A, or on the elevated path with the help of some external medium. Is it clear, my dear friends? Okay. So that is going to be the concept here. So this is head loss, and if you are checking that this head loss is occurring over this length, then you can say that your V is proportional to HL over L, and this HL over L is known as your I. Okay, this head loss per unit length. Okay, or you can say gradient. So V is proportional to I. V is proportional to I. So let me know if you guys are having any doubt here. Although all these are experimentally noted, but these things are quite clear. Okay, these things are quite clear. It can be filled with the help of common sense. Okay, so I'm going to call this I as, so anybody, hydraulic gradient. Okay, and if you want to remove the constant proportionality symbol, so V is equal to K, V is equal to K I. Okay, V is equal to K I, and this K is called as coefficient of permeability. This K is called as coefficient of permeability, that your V is directly proportional to I. Okay, so V is directly proportional to your I. Is it clear? And the constant which is going to relate them is known as the coefficient of permeability. Obviously, for a given head or hydraulic gradient, I am having two hydraulic gradients. One is 10 and another is 20. So, in which do you think the velocity is going to be more? Okay, so velocity is going to be more, is going to be decided on the basis of this coefficient of permeability. So where the coefficient of permeability will be more, in that case you can say it is going to have higher permeability, or it is more permeable, and you will be seeing the similar stuff in your coarse grain soil in comparison to fine grain soil. Okay, my dear friend, one more thing I want to share with you, that if you are increasing the flow rate, let's say if the pumping velocity or velocity, if it is very less here, then the relation between this hydraulic gradient and velocity is going to be almost like this. But after that, it is maybe like this. So if you are going to increase the velocity, then this linear behavior is going to be converted into non-linear behavior. So that is the reason why I am calling that this flow is valid only at low velocities. So most of our soil velocities are low only, so we will be able to uh, use this straight line linearity. Okay, so whenever it is written that your fluid is you can say Darcian, so it means V is proportional to I, you can always use. So Darcian fluid means that fluid in which the V is proportional to your I. Is it clear to all my dear friends? Tell me. I hope it is clear to all my dear friends. So this is your Darcy law. V is directly proportional to I, and it happens generally at low velocity at laminar conditions. So most of our soil flow through soil is laminar only. So this we can use. And similar thing, if you want to write in terms of discharge, then we all know that discharge is going to be equal to area into velocity. So this is equal to K I A. It is equal to K I A. So discharge is equal to K into I into A. So that is the thing here. ठीक है. So okay. So discharge is equal to KIA. Okay. Okay. Now the things come into mind that what are the various you can say ways by which we can find the coefficient of permeability. So these various ways are like your laboratory test, field test, indirect method. Okay. Okay, I will go to this topic maybe later, but before that I want to give the flavor of this, because in this time we will be able to complete it properly, and it is also interesting for you guys at round. So how we are going to define the permeability in the layered soil? Okay, you know layered soil. So it is a soil where you may be having multiple layers of the soil, as it is practical as well, because it may happen that on a top scenario and at the in crust only, but at the outermost point you would be having some loose sand. It may be happen that some dense sand or some clay layer you might obstruct. So if you want to replace or if you want to find the equivalent permeability of this layer system, okay, then what you have to do, first of all you have to identify that it is your just like parallel thing. Parallel thing means your discharge is going to be take place in parallel. So what used to happen in parallel, so like you all have seen these basic things in your childhood, in your ninth class only, or maybe in your 10th class only, that if the current goes in parallel, it has to be divided I1 plus I2 plus I3, and after that they again are going to merge together. Okay, this is the case. So here the division of current magnitude is there. Similarly, discharge will also be divided when it is a case of parallel thing. And what was the thing which were linking and keeping our bridge intact? That was the head loss. The head loss, whether you are going from this path or this path or this path, are going to be same. I mean to say not head loss, resistance, voltage. Okay, the potential drop between these all different paths are same. So similarly, if you are looking for a thing which will be able to give you the relation here, then you can think that if these are the discharges Q1, Q2, Q3, and so had the difference between here to here or here to here or here to here, all these head differences are same. Okay, so this is the funda of parallel, or you can say flow along the bedding. Okay, along the bedding plane. Okay, so this is one thing. Okay, and what is happening in parallel? What is happening in parallel? Oh, sorry, series. Series is just like your flow is across. Okay, perpendicular, or you can say the flow is going to be across. Okay, might be this is not very practical, but it may happens that water is percolating down and there are soil layer by layer. So if you are entering water from here, then it may be going down into the ground, and while it is going down, it might be facing these three different layers with different thicknesses as well as the different permeability. Here as well, my dear friend, you might need an equivalent system, or you may get to know the equivalent coefficient of equivalent permeability. Okay, this is your KEQ. Is it clear? This is your KEQ. A very good morning, Gaurav. Okay. So, what is going to be the idea here? So, here the things are in series. So, as you used to did in your series parallel connection, that if there are multiple resistance which are acting in the series, so current is going to remain same. So current is basically your discharge now, and voltage drop there is basically your head loss now. Okay, so here the current loss was similar, but the dropping was due to head. So from here to here it is one drop, from here to here it is two drop, from here to here it is three drop. Similarly, the total head loss between the extremities of these 2 points is due to the head loss due to this one, plus head loss due to this one, plus head loss due to this one. So this total H is equal to H1 plus H2. This head loss at through the layer is equal to head loss from first layer plus second layer plus third layer. This is going to give you the exact relation. I hope I am able to make the sense that what I want to say. Now the question comes into mind that how we are going to write these things. Okay, is it clear? Okay, thanks Archana. So now my dear friends, see, just now we have seen the Darcy's law, and we are coming to know that here in bedding parallel, or you can say along. Okay, from common sense, can you able to tell me that which value is going to be more? Is it going to be the parallel one, or you can say the perpendicular one? Okay, so you think of it. In the meantime, I am just giving you the expression that so what was the case here? Here the discharge was being divided. So I can say, I could have said easily that total discharge across them is going to be individual discharge Q1 plus Q2 plus Q3. So total discharge, or you can say discharge of this equivalent system, you can write it as, from Darcy law it is KIA, isn't it? Just now I have seen, now we have seen what we have seen earlier, that Darcy's law, that your velocity is proportional to I. If your velocity is proportional to I, and if you want to write the discharge, then you have to multiply the velocity with the area of cross section. So area of cross section is a capital A. So discharge is equal to Ki, which is velocity into area. Okay, so that is going to be the case here. Okay, that is going to be case here. So now see that KIA, area's cross section, and this area of cross section is there for this thing. So what is going to be the area of cross section, we will see into that. And this is equal to Q1. What is Q1? Q1 is flow through this layer. It is K1 I, or you can say your A1. Similarly, plus K2 I is going to be same, I into A2, because I told you in parallel connections drop is going to become same. Similarly, in parallel the head loss is going to become same. Doesn't matter whether you are going from this side or this side or this side. So between 2 points, all these 2 points are at some individual potentials. So there must be one potential difference between these two. Okay, and third one is K3 into I into A3. So I is going to be cancelled. So K you have to find it out. I, all these are, because same length is there, same head loss is there, so I over L is also going to be constant. So doesn't matter whether you are checking I for this or for this is going to be remain same. So this K is equal to, what is A1? A total A I you can write as H1 plus H2 plus H3. Okay, let me use the another page. So what is the total area? Here H1 plus H2 plus H3 multiplied by depth. Okay, what is A1? H1 into depth. What is A2? H2 into some perpendicular thing. So you can take it one and all. So you can say that K equivalent into H1 plus H2 plus H3 is equal to K1 H1 plus K2 H2 plus K3 H3. Or similarly, if you want to simply find the, okay, so this is the formulation for getting the value of equivalent coefficient of permeability with the help of this basic series parallel connection. So the thing is, what I need to see, these things you are going to encounter into 3 to 4 ways or n number of ways in civil engineering. Whether it is a matter of spring connection, there also this series parallel things has to be considered. When it comes to flow through pipes, okay, pipe networks, there as well you have to think of this series and parallel connection, and in here as well, okay. But my dear friend, always keep one thing in your mind, that you should be identify that thing which is going to remain same and which is going to divert in your series or parallel connection. So there would be always a clue for you guys, like parallel means here in electricity means it was potential drop same, here it might be head loss same, okay. Similarly in your fluid mechanics across pipes, there as well head loss is same, okay. And what is the thing which is going to divide? It is discharge here, it is current here, okay. Maybe in spring when we are talking about, it is force there. Is it clear or not? So you do not have to by heart all these things, okay. But yes, here you can if you want to find the flow through parallel, then simply you can take the weighted average, okay. It is simply your arithmetic average, or you can say weighted average, okay. And now second thing which we have to consider here is another format, that here the permeability through the stratified soil, and here we are dealing the across flow. Here we are dealing the across flow. So what is going to happen? So see here what is going to happen here. So here you can say when you are going from here to here, or some authors can also putting like this, K1 H1 plus K2 H2 plus K3 H3 like that. Okay, some may even put like this. So here you can see this is going to be the path. This is going to be the path. And here you have seen that discharge is going to remain same. So discharge here is going to remain same. So you can say the total head loss, okay, the total I or total head loss is equal to head loss due to A plus head loss due to B plus head loss due to C, okay. So all these things is the key point here. So now this head loss, how I am going to write, we know that uh, you can say Q is equal to K head loss over L into, you can say, A KIA. So A is also we will see how to write, but what is head loss? Head loss is your QL, okay, upon AK. What is L? L is the length of flow. What is A? A is also this cross sectional. A is also this cross section. Okay, and area is going to remain same here. If it is water is passing through here, it means it is also passing through here from an equivalent system. So area of this individual three layers, cross sectional area, and here it is going to be remain same. So head loss you can write like total discharge, which is going to be same. And what is the length? What is the length here? Length of flow. So length of flow would be h1 plus h2 plus h3. h1 plus h2 plus h3. Okay. Over A into K, over A into total system equivalent permeability. It is going to be like this. So this is equal to, my dear friends, HA. What is HA? HA is from here to here for 1. So Q is going to remain same. L is your H1 only, because L is the length of the path which it has to take for the corresponding head loss. So it is going to be equal to Q L over A into K1. Similarly, Q L over A into K2. Why I am taking L this, you know na? Because from here to here the path followed is H1 only. From here to here the path followed is H2 only. From here to here the path followed is H3 only. So like that I have to write here plus Q H3 upon A K3. So area is going to cancel, discharge is also same. Okay, so now if you want to write the equivalent, then equivalent coefficient of permeability, it is going to be equal to total possible thicknesses or total possible length of flow divided by h1 over k1 plus h2 over k2 plus h3 over k3. Okay, so this is known as your equivalent coefficient of this is known as the equivalent coefficient of permeability in your, you can say, which type of flow, in your across flow, or you can say in your series type of flow. So my dear friend, sometimes earlier I asked you one question that out of these two, which is going to be your more, or you can say which is going to be your more and which is going to be less. So the correct answer here is your discharge. Okay, you can say your discharge, although it is going to remain same here, but in case of your you can say parallel flow, this is arithmetic mean. Okay, it is geometry, it is arithmetic average, or you can say it is arithmetic mean. And in case of your across flow, it is harmonic mean. And we know from childhood only that our arithmetic mean is greater than equal to geometric mean, and it is greater than equal to harmonic mean. So mathematically this thing can never cross this, or you can say this is always going to be greater than that of this one. So my dear friend, this is your arithmetic mean, this is your harmonic mean. So the flow rate, or you can say the coefficient of permeability, flowing parallel to the bedding plane is more as compared to the coefficient of permeability flowing across of the bedding plane. Okay, this is one way of thinking. Logically also you can define this stuff. How you can define this stuff? See, if I am having here some layers like that, like say it is going to have very less conductivity or less K value, but it is having, let's say 1, it is having 20, it is having 22, like that it is going to have. When it is going to be like that only, so your water may be passing from here or here. Okay, it may be passing from here and here, and still you can make some good discharge. But suppose if sim 120 22 is occurring here, if 120 and 22 is occurring here, then my dear friend, even if one layer which is having the lesser value of hydraulic conductivity is going to block your water, is going to accumulate your water. So here the things can be run even parallelly. Okay, if water is not going to go from this side, then it will take this path or this path. But here, if one blockage is there, then we do not have any escape plan here. So discharge cross section has to remain same. So doesn't matter whether K2 and K3 are very high, but if K1 is low, then not only in starting only, suppose it would have been 20 and it would have been 1 and 22. So water will flow from here to here from good rate, but after that what will happen? Again it will start accumulating because the value of permeability is very less. It may be a layer of clay or silt which is sandwiched between the two layers of gravels like that. Okay, similarly you can see here. Okay, so across flow or parallel flow is always going to give you more discharge as compared to along flow, or you can say across flow. Okay, so mathematically also it is justifiable because it is your geometric arithmetic mean. It was your arithmetic mean and it was your geometric mean. So we can now write that your arithmetic mean is greater than, so it is not a geometric here, it is harmonic mean. Harmonic mean. So you can say that your arithmetic mean is greater than geometric mean. It is greater than harmonic mean. So equal to sign will also come. Equals to sign will come when all these discharges are like same. Okay. If K1, K2, K3 are same, in that case both of them are coming to be same. Otherwise your arithmetic mean is always higher. Otherwise it is going to be always higher. Is it clear to all my dear friend? Is it clear to all? Okay, so that is going to be the case here. So these two important formulation with the concepts I try to make you understand. So in today's lecture my dear friend, what we have covered, I have given you the basic definition of permeability. After that I was trying to establish the relation between discharge velocity and seepage velocity, and from there I came to know that my seepage velocity is more than that of the. After that we have seen the Darcy's law, that V is proportional to I. What is I? It is head loss over you can say path of flow. And how to write the head loss? It is the differences of the total heads. And how to write the total heads, that we have seen. It should be the summation of piezometric, datum as well as kinetic head. But we have seen that our Darcy law is going to follow only in the laminar condition, and most of the soil conditions of water percolation problems are laminar condition only. So that assumption is justified. Okay. So whenever the word Darcy law, Darcian soil is coming into the consideration, so we have to make sure that yeah, V is proportional to I. This is what your Darcy's law, or V is equal to Ki. So this K is known as your coefficient of, you can say, permeability. Is it clear? And after that we have seen the application of this Darcy's law into the series and parallel connection, or you can say in along and across connection. Okay, so in along what is going to happen? It is going to be the parallel, and parallel means arithmetic mean. So just think like that. Parallel would be more now, because across, if only one blockage is there, then entire discharge is going to disturb. So what you can think here, that parallel one will be more and perpendicular one would be less. So what should be the arithmetic mean? More one, because arithmetic mean is always greater than harmonic mean. So in parallel the equivalent would be arithmetic means K1 H1 plus K2 H2 plus K3 H3 dot upon K1 H1 plus H2 plus H3. And similarly, what is going to be the formula of across? Across means perpendicular one. It is harmonic mean. Harmonic is mean is what? Okay, the sum of all the thicknesses upon H1 over K1 plus H2 over K2 plus H3 over K3. Is it clear to all my dear friends? Tell me. Is it clear to all? So by this concept we will be able to solve the numerical. So obviously I was having numerical, so maybe we can try at least one. So this we have not done, this we have not done, this yeah, try this one. Try question number 3. You all of you go for question number 3. So in a 2-layer soil system, okay, in today's PDF I will mark it question number 1 and I will send you. In today's PDF I will mark it question number 1 and send you, don't worry. Okay, question number 1. So what is going to be the answer? In a two-layer soil system. Okay, let me solve it. In a two-layer soil system, first layer, second layer. So both of them are going to have same thickness. It is going to have same thickness. Okay, and the coefficient of permeability of topsoil is twice. Let's say it is let's say if it is k, it is equal to 2k. When the horizontal flow occurs, okay, when the means the flow is going to be parallel, the equivalent coefficient of permeability of this system, it is quite easy, my dear friend. Horizontal flow means what? It is parallel flow. Parallel means along flow. Along is arithmetic mean because it has to be more. So the equivalent permeability is equal to 2k into h plus k into h. Total thickness is h plus h. So it is equal to 3kh by 2h. So 3 by 2, 1.5. So this is going to be the correct answer for question number 1. Okay. Is it clear to all my dear friends? So rest of the questions we will be covering tomorrow, because before that we have to see some few more concepts there. Okay. So we will keep it up to here only, and we will be discussing several more numericals tomorrow. Okay. We have to see what all are the various way to obtaining the coefficient of permeability in the laboratory as well as in the field. And in the laboratory we have to see in the derivation of constant head permeameter, variable head, falling head permeameter, and what all can be the empirical relations which are useful for determining the coefficient of permeability. Okay, so all those things we have to see. Is it clear? So we will keep the session only up to here, my dear friend, and tomorrow obviously we will be continuing the permeability, and the topic would be coefficient of permeability by laboratory and you can say field method. Okay, okay, so that is the case. So this is, my dear friend, some of our work at YouTube, and if you have not been into Unacademy Gate CECS, then you can be, and you can actually crack your Gate ESE with the help of our comprehensive courses which we did on, you can say, or which we are doing on Unacademy Gate CE and CH. Okay, is it clear? And my dear friend, here is the information of some of our upcoming batch. As you can see that on 8th Feb, we have started our Evolve batch for civil engineering, where our top educators are actually started this batch. And if you are looking for 2-year plan, for if you are targeting for Gate 2023, so that batch also started on 8th of Feb, and here we have designed this course for 2 years. So you can be a part of this batch by using the code S10. And my dear friend, all these are the, you can say, batches for journal studies, so which is going to start tomorrow only. And if you want to be a part of this journal study batch, then still you can take the help from my code, which is going to be S10. Okay, so all these are the prices of Unacademy plus subscription. As you can see that for 1 year, my dear friend, you might have to pay 27,225, and for 1.5 year you may have to pay 34,650, and for 2 years we have to pay 39,600. But soon these prices are going to increase. Why? Because the discount which you are having 10% now, it will be 5% very soon, my dear friends. And it's my suggestion that if you are targeting your gate or ESE and you are in a mood to think that you want to take, then do it now, do it fast, because it may be converting to 5% discounted rate at any point of time, maybe even tomorrow. Okay, so similarly, if I'll say if you want to buy the iconic plan, so that iconic plan, you have to pay a little bit extra. I told you the reason behind that at very beginning, that for that you have to pay 45,225, and for 2 years you have to pay 66,600. Okay, why iconic is costlier? I told you because in iconic we are going to provide you plus features are incorporated, but other than that we are going to provide you a personal coach who used to design plan your study, who used to keep the study booster session for you, who is going to analyze your test, and based on that you would be getting some specialized notes and practice sets on the daily basis. So that is the reason why that subscription is slightly on the higher end. And guys, you can always follow me at Unacademy at the rate Sharma Aishwary -1049, and this is our official Telegram channel. I am going to send notes of this class in this channel just now. And all these are the various channels offered by Unacademy, and right now you guys are watching me at Unacademy Gate CE, also known as the one-stop solution for all civil engineering problem. So thanks a lot guys. Thank you. Have a nice day. Stay safe, and yes, don't go outside if it is not required. Have a nice day ahead. Bye bye.